So far, we have seen two different ways that we can solve a system of equations. And the first way was graphing, which possibly is the easiest. However, it tends to be the least accurate, unless we have really professional equipment for graphing. Algebraic solutions, we realized in the first part of this lesson, when we did substitution, are far more accurate, though maybe a little more tedious with the math involved. Some people really enjoy substitution, and once you learn each way, will always use substitution. Other people like to use this third method, which is called elimination. And yet, other people look at the problem and decide, is that one easier to eliminate, or is it easier to substitute? If you have enough time, the ideal situation would be to solve it both ways and double check that you get the same answer. You could even solve it all three ways. Try graphing, substitution, and elimination. If you get the same answer 3 times, you're pretty sure you're right. But in order to eliminate, you must understand that we can combine two different equations. If we have a system of equations, we can combine those together in order to solve it. If we were substituting, we'd isolate one of the variables, say for instance y, and then we'd substitute whatever y equals into this equation. Some people would look at this and say, well, if I divide by 2, I have odd numbers here. That's going to give me 5/2, 7/2. I don't like fractions. I don't want to do that. So another possibility is what I was talking about, eliminating. What if we wrote the orange equation, 2y plus 3x equals 1, immediately under the red equation? If we wanted to combine those in such a way that the y got eliminated, we would look and say there's 2 y's here, there's 2 y's here. The way to eliminate is to subtract. If I subtract these two equations, there won't be any more y's. 2y minus 2y is 0 y's. 5x minus 3x is 2x. And 7 minus 1 is 6. Now we have an equation with just one variable. Dividing both sides by 2, we get that x equals 3. We know that's half our answer. At this point, it's pretty easy to substitute back in and say 2y plus 3 times whatever x value is 1. We know our x value is 3. We would say 2y plus 9 equals 1. Subtracting the 9 from both sides, 2y equals negative 8. Finally, dividing both sides by 2, y equals negative 4. And our final solution would be 3, negative 4. Notice we still substituted at the end to figure out the other variable, but our initial step to figure out the value of one of the variables was simply to eliminate. In this instance, that elimination worked really well since the y's already had the same coefficient. That's the key to doing these, getting the y's or the x's to have the same coefficient. In this case, 5 and 3, the lowest common multiple would be 15, so you'd have to multiply this one by 3, multiply this one by 5. That's a lot more difficult than simply just matching up the y's that already matched. But sometimes we do have to alter one or both of the equations in order to eliminate. We have an option here. Either we can make the x's match. The lowest number that both 3 and 7 go into is 21. So we'd multiply this entire equation by 7, this entire equation by 3, and then we could eliminate the x's. However, you can tell it's much simpler to match the y's. What could I multiply the orange equation by so that the y is matched? Exactly, 2. If I multiply this entire equation by 2, the result would be 2y plus 6x equals 4. I'm going to take this and write it immediately under the red equation. 2y plus 6x equals 4. In order to eliminate the y's, I would subtract. 2y minus 2y is 0 y's. 7x minus 6x is 1x. 4 minus 4 is 0. So we know that x is 0. When these two lines intersect, it's where x equals 0, or in other words, on the y-axis. if I substitute this back in, let's say to the smaller equation, the one with the smaller coefficients, I would say y plus 3x equals 2. I knew that x was 0, so I would say the value of that is y plus 0 equals 2, or more simply, y equals 2, making our final answer 0, 2. And that is the answer to the system of equations. It's the point, It is the point where those two lines intersect one another. That's all you have to do.